Welcome to episode 4 of The Front Row, brought to you by Anthem Electronics. My name is Ryan Charpentier, and we're going to be jumping in with Eric Bodley from Future Ready Solutions to talk about HDMI, what it is, what the history it is, and a little bit more of a higher level of how it operates. We're going to talk about, in another episode, some more granular detail about how HDMI works. But if you have any interest in learning about how HDMI operates and where it came from and why it came about, this is going to be a good episode for you. But before we get into that, a word from our sponsor.
Anthem isn't just about power, it's about precision. From clean amplification to intelligent room calibration, every element is engineered to deliver pure articulate sound. Unlock the performance your system was made for. Anthem. Elevate, refine, enhance.
Welcome into episode 4. This is going to be where we talk about HDMI. I think it's going to be a pretty important topic for not only us in the enthusiast crowd, but also for the industry as a whole. I'm joined, as always, by Eric Bodley, editor-in-chief of AVS Forum, but also by Eric Bodley, president of Future Ready Solutions. So how are you guys doing? Eric, anything noteworthy this week?
Well, we're both named Eric.
Yeah, that's going to be confusing. So I got to figure out a better way to do that. But Eric Bodley, we'll start with you. Anything noteworthy this week? You just got back from Infocom. Hopefully that was solid.
That was very solid. It was the hall was full. It was good attendance. A lot of inquisitive minds. I am kind of surprised at how dot pitch on video walls is just getting more and more crazy. I mean, some of these video walls were amazing.
Well, I think trending in a certain direction, things moving is really beneficial. And the cool thing, while other conventions have seen a downward trend coming down in attendance and hype, Infocom and things surrounding a good part of the AV industry have seemed to be trending this way, which is, I'm going to say for me, kind of unexpected, but a good thing, I think, for our industry as a whole. So glad that went well. Eric, Wesley, how have you been? I haven't talked to you in a few days.
I know, it's been a while. It's been a while.
Okay, it's been a while.
Yeah, I've been good. It's nice and hot out here in Las Vegas, so I'm getting the opportunity to stay inside and watch a lot of movies. So.
But no humidity. I'm jealous of that.
Well,
humidity is coming.
I can tell you, Orlando was brutal. It was 90s and 100% humidity. But I will tell you, that convention center was cold. I was very happy about that.
That's good.
We're in Florida, so.
Our humidity is coming. We're in the 80s% right now and in the 80s, but we're going to get hammered here before too long as we move into July.
Yeah.
We'll eventually pass you guys in Florida. We don't stay there long, but Kansas has a tendency of just making it miserable. I don't know why we live here, but we do. So Eric Bodley, we're going to talk about HDMI, right? This is a pretty important topic because as we talked about with Jason, a lot of people talk, or we mention HDMI all the time, but people really don't have an understanding about how it works. And I've always come to the idea of, if you better understand how something works, you have a better understanding about how to implement it and troubleshoot it. So I'm hoping today, with your guidance, that we can enlighten those that are joining us on this podcast, on the front row from AVS, and help everyone along this. So I'm going to turn it over for you, and we're going to go through and we're going to ask some questions along the way. But let's start with who you are, what a little bit about your history is. And I know I didn't mention that at the very beginning, but just a little bit about who you are. And then I want to talk about what HDMI is and where it started. So we'll kind of give the history of you and then the history of HDMI.
Good. Yep. Well, I'm a very old guy. Been doing this I'm 71 years old. So
you do not look 71.
I know. Everybody tells me that. But I started actually in 2-channel audio with a retailer in Florida in 1972, delivering and setting up 2-channel audio systems, high end at that time. Went to work at a retailer called Sound Advice, which we grew over the years and to 28 stores. And I sort of escaped from Shawshank there and did do work in the starting in 95 until 2009. I worked with Monster Cable, who became the sort of the tip of the spear in high-end cabling, and many companies, Audio Quest and AV Pro Edge and There's just hundreds of companies. Ethereal kind of followed behind the machete path that Monster Cable made. I brought all the custom installation products to market.
Okay.
So, wire packaging that you didn't cut your hands open when you tried to open it, and some of the first releases of HDMI. And I currently am president of Future Ready Solutions, and it's sort of an anecdotal story on how it started. At the end of 2009, 8 and 9, when the housing market blew up, I was recruited by a company called PPC, which owned the patent on the F connector, if you could imagine that. And they still make several million a day and sell to little companies like Comcast and DirecTV and
Just the little guys, right?
Yeah. And one of their engineers had developed, HDMI was just getting ready to emerge with the specification called 1.4. So there was original 1.0, I believe it was 2003. I think that's when
roundabouts there.
Somewhere way back there. And it was sort of a miracle it actually got invented. I'll get into it, that it happened. But I was recruited away from Monster by PPC. They had developed a locking HDMI, mechanically locking, where when you push the cable in, the head shell slid forward and it expanded. There was a metal plate that lifted, and you could literally lift a product up, a DVD player up by it and shake it. It would not detach. Now, unfortunately, if someone bent it a lot and everything, it would almost become impossible to attach. But it was very popular, mainly in the commercial world, where we saw hotels. I mean, you know, they don't want things to become disconnected. And they were acquired by Belden, the big wire and cable company, and I negotiated a deal to take all our dealers captive in a distribution company called Bodley and Associates, B&A Distributing. And I changed that pretty rapidly to Future Ready Solutions, which is really what we try to be ready for, is next. Not today, but the next generation. Because it was only 12 years ago we were installing 10 100 base T networks.
Yeah.
Now we've surpassed gig, and we're on to 10 gig and beyond. So this doesn't sit still. And I was sitting around, I think, with a bunch of my CEDIA buddies, and they wanted to know, what are you going to do? And I said, well, I'm not sure. And someone said, I wish someone would figure this HDMI thing out, because we're trying to connect product A to product Z, and we could have 5 or 6 things strung together. A short HDMI cable going into an HD base T transmitter. Then we have to craft and put connectors on category cable, and we go to a receiver, and we have another HDMI cable, and that could be 5 brands. And when it doesn't work, who do we call? So I said I could do that. And so Future Ready really was born out of vetting the transmission line, if you will, that it absolutely positively worked. Or as our motto is, don't install a service call, because so many people install service calls. It's stupid.
That's a great way to look at it, actually.
I like that.
So all of the products we sell are primarily geared around connectivity. In the early days, good friend of mine at HDMI Licensing, who used to work with me at Monster, he was head of marketing, Brad Bramey, and Steve, who was the president at that time of HDMI Licensing. It was sort of a miracle that HDMI was chosen as a standard. It really wasn't HDMI.org, the organization, a licensing company. It was the HDMI Forum, as it's referred to now. And there were only a handful of companies, and they're exactly who you'd expect: Sony, Samsung, Panasonic, Matsushita, as they were called. And they wanted a standardized way to do this high-speed transmission of video. Video had gotten way more complicated, much higher resolution. Heck, we were now at 720p. I mean, wow.
And for the time, that was huge. I mean, that was a big deal.
Big jump in clarity, performance, but we couldn't do it over a piece of coax or twisted pair directly. So engineers, somehow the planets aligned, and they actually, on one day in April in 2001 or whenever it was, they actually agreed and signed the agreement. And I don't think this could have, I mean, this was one of these inflection points, and then poof, it went off into the ozone layer. I don't think it could be pulled off today. And so over time, we sort of had everybody lay their weapons down at the door, and they all agreed to do it one way. Now, history has shown that, we had S video and we had composite video and RGB, and we had all sorts of wacky ways to transmit better video. But this was the first time they sort of took it all into play. And it moved along at what we would call 1.0. It actually didn't have a version number. And they came up with some iterations. Most of the changes, the dot something, dot 1.1, 1.2, until they got to 1.4, were just a lot of times just testing standards. You have to do this because this is the test. So these are now requirements to be in alignment. And one of the problems was HDMI. They formed HDMI licensing. That way they could make sure that if you want to use the term HDMI, which, by the way, a lot of people don't know what it stands for. I want to look this up on my phone because a good friend of mine, Chris Kane at AV ProEdge, texted to me this when I was at Infocom last week. So HDMI actually stands for High Definition Multimedia Interface. Mm-hmm. A lot of people don't know that. Chris suggested, and I have my own version because he knows I like acronyms. I named it High Definition Made Impossible.
Yes.
Chris texted me, hugely disappointing media interface. There's a lot of cursing going on, but it was really a standard. And probably the biggest jump was in 2009. And I was at CEDIA, and we had just launched. We were ready, we're certified, and with Perfect Path, which was that locking HDMI cable, we were the first to release a 1.4 HDMI cable, plus a locking mechanism. So we went from 0 to 60 pretty quick, and everybody.
So when did HDMI 1, you said it didn't really have a version number, come out? It was early 2000s.
Yep.
And then it took many years before they made it to what now going back is probably, it's rudimentary, but before 2.0, that's probably as far back as a lot of devices support. It took almost a decade to make it that far.
Yeah, 1.4 was 1080p as we know it. Now, color space and refresh rates and a lot of the other things that it's like saying this car has 200 horsepower. That doesn't tell me anything about the car.
Right.
It doesn't tell me about how it rides, how it handles, steering. There's all of these parameters that really make a driving experience. Horsepower is just part of it.
Right.
So how many lines of resolution, that's just drawing lines. What's the quality of the lines? The color dots that are in there. There's a number, and then we get into sampling. Probably one of the more confusing things, we were at, that would have been HDMI 4. I don't even think it was 420 back then. I don't know what it would have been, but 1.4 brought us to 420.
Right.
Which in a technical, when you look really close at a line, there are 4 dots, and 444 means each dot is an individual piece of information. When you say 420, what you're doing is you're taking, see if I can remember this because I haven't explained it in a long time. You're taking 2 of the dots and you're saying, I'm just assuming that the fill would be here. It's interpolated.
Right.
And so it isn't you're not really watching all 4 dots in real time, real data. It saved a lot of bandwidth. And it's all about bandwidth. It's all about frequency response, really. And we're into the megas and gigas here. So we went through 1.4 and it held pretty solid. People caught up. We found out who the good cops and the bad cops were, who was cheating, who wasn't. And then we went to 2.1. I'm sorry, 2.0. And that was a pretty big leap. That's when we first saw 4K come into the picture. I want to say that was 2018, 2019, somewhere in that area. I could be off by a year or two. And that was a big jump. But we were refreshing the screen at what we call 30 hertz, which was half of the frequency of the electrical system we use here in the States. And then they moved to 60 hertz refresh rate. That just means we're redrawing 60 times a second. And the 1080p video the maximum native capacity was 10 gig. And so inside the cable, when you stare down the barrel of an HDMI connector, there's a lot of pins in there, 19 of them, I believe. And they're all copper. They're all wired. It's done by a machine. I argued with this whole tariff mess that we're in, that moving HDMI production to the U.S. is a 5 to 8 year process, not just for the equipment, but to train the people, because the people who are making HDMI cables, and these are not all done by pasta machines and stampers. There's a lot of hand work done. Factory I was at in Shenzhen 6 years ago had 28 people, 14 across from each other, literally passing piecework and testing 3 or 4 times down the line. It moves very rapidly. These people we're now into second and third generation Chinese nationals making this product. It's a craft, and it's like being a painter or a sculptor. It's not something you just do a Vulcan mind meld and someone learns it. You don't think about it in a book. And so the hardest thing is transferring that craftsmanship. And unfortunately, because China won't allow their citizens to leave, we can't just hire them and bring them over here. So it's a mess. So we went from 10 gig, and inside that, there you'll hear lettering and acronyms, TMDS, and things of that nature. We're not saying, when they say something is 18 gigabits of data transfer, that sounds incredibly fast. But the truth is, in the beginning, when we used only copper, there were 3, let's just say red, green, blue. That's just simpler to understand. We had 3 lanes of video on a twist, each one on a twisted pair with a drain wire, a ground, transmitting part of the image. And then we had a way to synchronize that because it's like a metronome. All 3 lanes had to stay synchronized. And then lower level data, like audio, we could transmit over copper because the bandwidth is 20 to 20,000. That's pretty minuscule compared to video. So everything had to stay lined up. And we had to poke down there and say, look, hey, somebody down there, I'm going to send you some video. And the display would wake up from this voltage that came down, and it would send back, they call it a handshake, and it would say, yep, I'm here. And it would send this whole packet of information. Here's who I am, what I can do. Here's how many lines of resolution. Here's the color depth. Here's the refresh rate. These are the levels of performance I can do. Now, the source, whether it's a cable box or a DVD player, Mad VR, or a Apple TV, that source has a certain capability of what it can send. And it can do several. And what it wants to do is do the best fit. So hopefully the highest performance. So an Apple 4K TV is going to try to go, all the way. But that display may not be able to do that. So they handshake back and forth, and they sort of, okay, I have an agreement of what we're going to send you and that you're going to display. All of that goes on super fast. So 19 wires in a cable, and treated badly by installers in the field, I might add. It's not speaker wire. And so the construction started to becoming critical. Now, the other thing that happened during the Big Bang, if you will, when these 4 or 5 huge manufacturers standardized this, is they didn't think about a custom installation. Their thoughts were, I'm going to have a TV, it's going to be on a stand, we're going to have a cable box or a DVD player, and it's going to be right there. We're going to make, 1 meter cable be long enough, right? And enter the integrator. And all of a sudden, nobody wants all that crap on their credenza. They want the TV mounted. And so we need to remotely locate the sources, and hence the equipment rack concealed and not making a lot of noise in our viewing area. And we needed longer cables. And that was a challenge because there's so much voltage and so much communication going to all these tiny copper wires. Copper has resistance. It just can't do it. And I got to tell you, we're wringing out category cable now like a sponge trying to get much data through this thing. And it's, oh goodness, engineers have come up with all sorts of compression techniques and this and that and handshakes. but it's reached the max. And in fact, when we made the next step to HDMI 2.0 and 2.1 and coming, who knows when, 2.2, we've gone to 18 gigabits, which is a true 4K high HDR, and we're at 18 gigabits. Now, that's a little disingenuous. It's not 18 gigabits. It's 6 gigabits on 3 lanes if you're in copper. And when we went to 2.1, we now have the ability, okay, we want to go 20, 30, 40, 50 meters, which is 60, 80, 100 feet or more for us Americans. Copper can't do it. So we convert from this voltage in the copper wiring coming out of the source, we convert it to light, and we do it over fiber optics. And that gives us incredible, I mean, fiber has at the lengths we use, it probably has close to 100 gigabits per lane of copper, and there's 4 of them now.
But back to what you just said, going to fiber, most cables are not using all fiber. You're still using copper for parts of it. And this is part where people, I think, see, oh, it's a fiber optic cable, it's all fiber. You're still reliant on voltage for some of this, and you're still running into Ohm's law, right? You're still beholden to the limitations of what is going on here. And we'll get to that when we start talking about some failure cases. So sorry to interrupt you.
No, good point. But what we needed to do is now we have to convert from copper to light. And we do that through the miniaturization of chipsets. And there's actually electronics in the head shell. And you'll see some head shells, in the beginning, they were very long. And the problem they pose there is you plug that in and sort of has a lever effect.
Yep.
I mean, if you pull on that cable, you're stressing out the inside of that jack. And as much as we want to curse it, the HDMI connector and port, the connector is what's on the cable, the port's what's in the hardware. They're pretty robust considering the stress and strain we put on them. And those connectors are on the top and the bottom of the connector and the port, 19 of them. So, and they, I used to have all the pinouts memorized, but it's become less of a discussion point these days. So these electronics in there take some juice. And so our first big hurdle that everybody was scratching their heads over was, why does this cable and why does this source work with some displays and not others, or vice versa? And what we discovered was the source is, as my friend Jeff Piccaccio at DPL Labs calls it, it's the queen bee. It starts everything off. It delivers a voltage down the line to the display, and the display just has to send back its Morse code telling us what we need to know about it. Well, these active cables, as we call them, whether they're copper with chips in them, and we still have those, or fiber optics when we get into lengths longer than 10 or 15 meters, those chipsets take some voltage. So they have to sort of, glom onto and capture a voltage harvest so that they can be powered. And that started causing issues because the source there was no spec to, you have to put out 5 volts and it has to put out 1 amp, let's say. Well,
before you continue, this is a point I never thought about. You've got the chipset that requires a voltage. You have that voltage needing to be applied to other things in the cable. Are you essentially saying that it is harvesting some of the voltage that would be put onto other buses in order to power the chipset?
Yes.
So
you don't
potentially
have fiber, you have to power up the
right, but potentially the harvesting could be creating problems because you're pulling voltage away from something else, right? That may need it down the line.
Absolutely did. Now, so we've got a couple of things that happened over time here in this whole 2.x realm. So we have sources. Apple goes from their original Apple TV to their Apple 4K TV. And earlier versions of it, they didn't have enough, they weren't putting out enough voltage. I believe the spec is you want to be at 750 mics or 0.75 amp. There are a lot of sources that had just right there. And that would meet the spec if everything was perfect in the connection. But if we introduce something that draws some current, it could drop below the threshold.
Now,
And
also there is
necessarily
that
immediately.
also there on that particular voltage spec. Am I mistaken in saying that it's a window, like you have a variance that you can meet, or do you have to meet that 0.75 amps?
Well, I believe today there's more solid on this, and I don't have all the research on that. But what I do know is companies making sources were getting these complaints, so they over voltaged in
Right.
some of their versions.
Mm-hmm.
Certain products, serial number here to there was the original, and then they went to the next number and those had more voltage, and it caused other problems when you overvolt something. So then the display manufacturers realized that, look, we're waiting for voltage to come down, so they're now starting to work with voltages at their end
Mm-hmm.
because they need to send communication back. So what I will tell you is in the last year and a half, 2 years, we have seen some very good stabilization there. The real variable that's still a problem is quality of construction. And, you can buy, people come to me, some of the cables we sell are, let's say for a 2 meter, 3 meter cable, let's say they're $20.
Mm-hmm.
People say, well, that's just so expensive. I said, well, what are you paying for? What do you use? And I use XYZ, not so good cable off of Amazon or somewhere there. And it's like $10 or $12. So $20, that's just almost double the price. Now, what I like to ask the integrator that poses that is, let me ask you a question. What size projects do you do in dollars? Small, medium, and large. Small project might be 15,000, medium project 50,000, large project 100,000. I'm just picking numbers. I say, okay, well, take a medium project. How many HDMI cables do you use on a medium-sized project? And they'll scratch their heads. They may even pull out a proposal and say, we used 14 cables. 14 on a $50,000 plus project. So let me ask you, why would you cheap out on a critical product like HDMI connection? Because that's $140, right? You've got 14 cables, we cost $10 more. But what other product could you specify if you were able to buy the very best you can that absolutely positively works, that you're not installing a service call for $140 for that project? Right. And it sort of sobers up people when they think about how, as my mom used to say, penny wise and pound foolish. They were being about parts that are critical. It's not like a drywall screw. This is an integral part of the ecosystem.
Well, and to be clear here, you're not saying, because we're talking to enthusiasts a lot of this, so I want to make sure that people don't have a misconception here. Eric is saying that the things are not more expensive because X, Y, or Z wants to make more money. He's saying, at some point there is a line where spending a bit more is going to get you something better, right? So on a critical component that is connecting devices, as long as that money is well spent and in the proper way, spending a bit more to get a product that is almost guaranteed to work is well worth the peace of mind instead of just saving a bit of money, right? Yeah. Not everything, I want to emphasize that not everything, even if it's more expensive, is going to do this. But Eric has built his brand on testing into the ground products in order to make sure that what he says is true. So if he says, yes, it is going to provide you more stability and you're not going to be installing a service call, he's selling that, and he's selling the peace of mind as part of that. So I just want to make sure that people understand that.
Future Ready Solutions, our company, the only label in our industry that matches is distributor, but we like to think of ourselves as a technology solutions provider. Well, we carry 12 total brands, 5 what we call the Focus 5.
Mm-hmm.
And
you're very, very selective.
Very, very, and we have had, because we do imports and products exclusively, but it's my island. And if they don't make the grade, I vote them right off the island. There's a few brands I don't sell any longer. because technology has moved further. We developed our own brand, Lightspeed Technologies. We have a fiber optic transmit receive unit that runs on 2 strands of fiber with power supplies at both ends. So I don't have to worry about transmitting power back and forth.
So
Power's already there. We just
staying
need
on this topic, Eric, what would the difference be between a $10 cable and a $20 cable? What inside is different about it?
Well, there's a couple of things. And HDMI licensing has actually helped out, because initially they just said, here's the spec, follow the spec. But if people cheated, there was no way to verify. So they then moved into a program where you had to submit your cables for testing to what they call an ATC, or an authorized testing center. And there are several of them around the world. Cables are made in many, many different countries: Israel, China, Taiwan, Vietnam, I mean, all over the place. And I'm sure there's someone trying to make them here in the United States. I'm not familiar with anybody, but I'm sure there are. And you had to submit, if you made a 1 meter and a 2 meter, and a 3 meter, a 4 meter, and a 5 meter cable, you had to submit a cable to be tested. Now, what most people would do, hey, I'm going to submit my 5 meter cable, because longer is harder, right?
Mm-hmm.
And if the 5 meter cable passed, everything shorter than it was grandfathered in. The other thing is they realized that someone's going to find the absolute best one out of this production lot and send it in. And so it might meet the test. But how do we know that every cable is manufactured to what's the tolerance, the variance? And so HDMI licensing started doing something very interesting. They started going to the marketplace, and they would purchase the cables on a regular basis and would test them, and they would notify companies, we just bought something in the marketplace at a store or online, and this cable is not doing what you said it was going to do. Now, fast forward to the last couple of years, HDMI licensing has now set very rigid standards of whether you're a high-speed cable or an ultra-high-speed cable. And there's a holographic sticker that is, I think it literally cost the manufacturer $1 or $2 a sticker. It's that sophisticated, because you can scan that holographic barcode, and it will take you to the HDMI licensing site, and it'll say, yep, this is authentic. Because there's a lot of counterfeits in all sorts of industries. HDMI cable's not immune. And the other thing they did is to pass in this ultra certification program, you have to submit every length. So they have to pay, and this is costly. You have to pay, and you have to submit on a regular basis to the ATC. So if I have a 1, 2, 3, 4, 5, 10, 20, 30 meter, as far as you can go, the longest we make is a 100 meter cable, which is astounding. You can go 328 feet with a cable, and it works. And it's now, we'll talk about this latest standard we call 48 gig enhanced, and it passes. I mean, that is the toughest test right now that we know of. And every length has to be certified on its own. You can't just send a long one, and it's a bell curve with a lot of companies. They'll submit the sweet spot, and the shorter and the longer cables may be in or out of spec. So there's one reason we have cost differences. To do it right, there's a lot of verification and authentication going on. The other thing is kind of old-fashioned, quality of construction. You'll see a lot of cables have what looks like a rubber molded head shell. And I would argue there are 3 essential components. There's the internals, how it's soldered, and these are done by what are called wave soldering. It's not someone with a magnifying glass with a soldering iron tacking on 19 individual wires. These things they go in and they're all soldered simultaneously. When you look at them disassembled, which we every once in a while cut one apart just out of morbid curiosity, it is incredible how uniform those are, because those connections are right next to each other. And if there's any change in the physical nature, or they're too close or far apart, they create crosstalk issues. So there's a lot going into that part of it. Then we have the cable itself. Now, one of the lines of cable we have, we call a rack optimized cable for installing in a rack. What does that mean? Well, they come in 1 foot increments and they're quad shielded. That's double shielding, foil, a braid, another foil, and another braid. And yet it's still very narrow and thin. Why should that matter? Well, when you're in a rack with a bunch of equipment, or even a cabinet that just has equipment in it, noise is everywhere. We have fans, we have power supplies, we have products like a DVD player emits an incredible amount of RF and EMI noise. So we want to reject that noise because this very high-speed data can get very distracted by extraneous signals. And then the last aspect is the case of the cable. It's the head shells, we call them. The best ones we sell have a fully encased metal case around all the connections. And then it has a polycarbonate coating around it that is, it looks like plastic. So initial look, it might look a little cheaper than some of the totally shinied up cables. But the reason it's there is these longer lengths get pulled through a wall. They're going to scrape along things. I mean, we protect all the connections on the edge with a cap, but they're very slippery, slick, and rounded. So they pull when an installer is pulling a 20-meter cable, which is 66 feet approximately. They're routing it, putting it through holes they've drilled. They're not pulling it, they're feeding it and moving it. So all of that construction just costs money. Mm-hmm. So the difference between a $10 cable and a $20 cable, or a $50 cable and a $100 cable is you want to make sure it's just not profit opportunity, that there's technology and engineering and craftsmanship behind it.
And what I find amazing is a lot of the brands, because I'm an integrator, and a lot of the brands that you trust, while yes, you're saying they're more expensive than something you may find on Amazon, in comparison to virtually every other integrator brand, they're not more expensive in a lot of cases. So you're choosing what is the most cost effective in a lot of these. It doesn't mean that it's the most expensive. It means that it does what it needs to do, and it may be more expensive in order to get the job done. And I think a lot of people forget when they're installing something, if you're pulling something through conduit, it is just getting chewed up as it comes through there. And if it's not designed properly, or if the bends are too tight, or you're pulling on it really hard, it's just getting hammered as it comes through. And it's amazing that it even works as it comes out the other side in a lot of situations. So,
yep. Well, it's, again, failure rates are typically physical in nature, not electrical. Now, I'm not going to say that we have cables that somehow die. And they die. I mean, the electronics in these longer length cables are susceptible to voltage surges. Mm-hmm. So when they say the cable died, I like to ask, did anything else die too? Yeah, we had to replace the DVD player. It died. So it could take it. If it surges, God finds ground wherever it can. And if it wants your DVD player and your HDMI cable, he's going to take it. So, not everybody's immune to that.
Yeah.
The other thing I wanted to amplify is this whole challenge with voltage. There's a device that we started selling, Clearline, one of our brands, an AV Pro Edge bullet train. They made a little device that has a male HDMI connection, and it's about 1 inch long, and has a female socket and a little USB dongle on it. And we use this to actually supplement the 5-volt power. So when we had source issues with it having enough oomph, enough voltage, we could supply our own voltage. And they're not expensive. It's good to have them as something in your tool bag because it can solve some very significant issues. And we usually see it when someone's trying to incorporate an older source, something the customers owned for a while, or an older cable box. They have more of a struggle with voltages than newer products do. One of our brands, Cords, just released one that is 5-volt, and it actually is a regulated 5-volt. It's pretty unique. And, it's one thing, USB, the little wall warts or the jack on your TV or the back of a piece of equipment in your rack are not built with super high 5-volt regulation. So if they dip or move around, that's going to affect the voltage coming in. So this was a pretty interesting find. It was only so it's only $5 more than the original ones we sold. So that was a no-brainer.
Well, and it actually solves a lot of problems where some of the other ones don't. And you bring up a good point that, and I just want to highlight this before I think we can get into breaking down what makes up an HDMI cable. People need to think about even the really, really little things. Every little thing is going to affect this signal. You brought up the injectors. Little variances in voltages supplied by the source or an injector can hugely impact whether something's going to work, what maybe you get flashing or artifacting or anything else that can become prevalent because of that. And so when you're talking about shielding and stuff, it's not necessary that it's always necessary, but just trying to prevent anything from happening to this signal, a few dollars may be worth the hardship down the line.
Well, it's like wearing a seatbelt. It only has to work once.
That's true.
But we wear it thousands of times. Something I bought online from a big A company, this little device, it's an inline USB tester detector.
I have that same one.
Plug it in and it will tell you how many volts and how much current whatever you have plugged in is. And it's shocking how all over the place some of these devices are. So, you know, we do this work so our customers don't have to do this work.
Right.
And it's a moving target. Now, we're moving into a new realm. There's an announcement. If you go to HDMI licensing, they had 2.0, 2.1, 2.1B, you know, and now there's a 2.2 specification. And one thing I want to encourage your listeners and readers to understand that they have done something where they've defined the future of video probably 5 to 10 years out. And just like anything else, there's already 2.2 cables on the market. Really, what I would encourage people to look for is a really high quality 2.1 cable, because, you know, right now our best quality product brand has achieved, there's another third-party testing, Digital Performance Level Labs, or DPL Labs. Crazy guy, I've been friends with him for years. He heritages back to the days of Macintosh when he and Joe Profito, who owns a company called Tributaries, both worked together at Macintosh. And he has created the most elevated level of testing. It's now called a 48 gig enhanced testing. And it really, what we want to see is cables and products today meet the spec of today. And I'm telling you, there's a lot of stuff out there that just doesn't meet it. Now, what display companies and source, they've learned to dumb things down. And unfortunately, a customer can hit an info button and see, oh, I'm not doing 4K 60. I'm doing 1080p. What's going on with that? And that's because whatever is being transmitted and received is trying to give you a picture. There's not an installer out there. They would rather have a picture at a lower resolution, not full all-on performance, a black screen or an intermittent image, flashing bars, things of that nature. That's the kiss of death, because that's endless truck rolls trying to fix something that you can't fix bad quality or a bad match.
Makes sense. So what is the difference for those who don't know? What's the difference between HDMI, say 2.1 and HDMI 2.2?
There is a long list of things that they're getting ready to do. The biggest thing is right now, the number of lines that are drawn are generally 4K or 5K, depending on the aspect ratio of the set. And then, of course, 8K/10K. And we're right into the 8K level. Now, Ryan, I think you'll agree, there's not a lot of high quality, high-end 8K sources. There isn't even any material available for you guys to stream.
I think I could count sources on one hand pretty easily.
Yep. So the spec that we have now is, we're 2 to 3 years away from realizing that at its full potential. But there are cases, medical imaging, very, very large format screens. Remember, the more you blow a screen up, the more the small things affect the visual because you can get closer to the screen and see them. Not that I like to look at an IMAX screen from 10 feet away, but it's there. I mean, you look at even things like the Sphere in Vegas, which is the most incredible video experience. It's 24K. They film it on special cameras. It's all native material, but the dot pitch, the space, the black space between the dots is like, correct me if I'm wrong, 6 or 8 inches. And you're sitting way back from it, and you can't tell. It's just our eyes can't tell. So we haven't even gotten there with our 65, 85, 100-inch screens that we're seeing today.
Before we go into a high-level description about how an HDMI cable works, a word from our sponsor.
This episode is brought to you by the Anthem AVM90 and AVM70. Crafted with precision and purpose, these AV processors feature Anthem's advanced 8K HDMI 2.1 platform, offering 8K 60 and 4K 120 pass-through, HDR10+, VRR, and eARC for effortless performance. Anthem. Elevate, refine, enhance.
Welcome back. Again, this is episode 4 of The Front Row, brought to you by Anthem Electronics. I'm joined by Eric Wesley, the editor-in-chief of AVS Forum, and Eric Bodley, many Erics today, president of Future Ready Solutions. Eric, that was an awesome explanation on really the history of HDMI. So I really appreciate that, giving the people a better understanding about where HDMI came from and where we are today. But I think it's time to get a little bit more technical. We're not going to dive both feet first into this. If you guys want to do that, we can do another episode. But we're going to talk a little bit about, at a decently deep but a little higher level, what is HDMI? And then right after that, some common error cases and what those symptoms look like so that people have a better understanding of what it is and what to do if those things go wrong and how to fix them. So Eric, I'm going to turn this over to you again. Let's start with HDMI 2.0 and how that's structured. You mentioned 19 pins, and we talked about passive and active cables. But I think it's important for people to understand a little bit about things like, what is an EDID? Why is an EDID important? You shed some light about the negotiation process, but didn't really talk about what that is or why that actually happens. And then the voltages, fiber versus copper in an AOC, maybe all fiber optic cables, because there's a couple of those that exist, maybe some converters and the positives and negatives that those can create, things like that. So we'll just start at what is HDMI 2.0 and what makes it up?
Yeah, so when 1.4 came out, which moved us into 1080p, it was about 4 years later. That would have been 2009. In 2013, they introduced the 2.0 standard, and they moved into the 18 gigabit per second transmission bit rate. And that really opened it up. So we had native support for 4K and 8K, low 4K 60 and 8K 30 frames per second, respectively. And they added a feature called HDR, or high dynamic range. And so we've got 3 different things going on. We have the number of lines that are being drawn, and those start at the top, go down. Initially, we had interlaced, and we moved to progressive. What does that mean? Well, the interlaced, the original spec for video, we drew lines 1, 3, 5, so all the odd lines down the screen, and we came back in and filled in the even lines. And those were interlaced, the even and the odd. Progressive scan, which is pretty much all we do now, 1080p, which stands for versus 1080i, is progressive, and it draws line 1, 2, 3, all the way down. So it's drawing much faster. Then we have the next, which is that drawing is a frame. How many frames are we going to put up per second? The faster we do that, now, when we look at 24 frames per second, that's the standard for film, the old acetate film that we watch. So 24 frames per second is, somebody figured out that that's as slow as you can go without creating flicker, if you will, like the original black and white movies had flicker. They were moving in a much like 12 or 15 frames per second, maybe. So we went into 30 frames and 60 frame support. Then we have dynamic range. Dynamic range is from black to full white, everything in between. So how much range can we get to our contrast, if you will? And they created more dynamic HDR, and that was introduced in 2013 and pretty much stood the time until 2017. And they came out with a revision called 2.1. I've always argued they should just made it 3.0 and been, made us feel like, because it was a pretty big jump, because they went from 18 gigabits transmission line to 48 gigs. Now, it's a little disingenuous. The 18 gigs inside the cable, we're dealing with initially 3 lanes,
right,
of 6 gigabits. That added up to 18. So the additive, makes it sound faster than it really is actually transmitting at. 48 gigabits, they actually split it into 4 lines. These are individual pairs of copper with a drain wire and a ground. So it's 3 conductors, a ground, and then a positive and negative signal. And they need that shielding, the ground around it, to keep the different voltages from talking to each other and to avoid any extraneous noise from getting on the signal, which will create noises like white speckles and lines and all sorts of artifacts, as we call it. It also keeps the signal from being interpreted correctly. That's why you get those little boxy sort of distortions sometimes on the screen. So now we have 4 lanes, but it's 12 gigabits per lane. So it's much faster. That native support, now we have 4K and 8K resolutions at 120 frames per second, and of course 60 frames. What did that get us? Well, when you have a very fast moving object across the screen, it's got to draw that and account for the speed, and the pixels, if you will, the individual dots, sort of can't keep up at 30 and 60 frames per second. So, I remember watching a basketball game where someone took a really long shot and the basketball actually disappeared minimally because it was moving fast enough to where it could not keep track of where it was. 120 frames per second, race cars, fast moving, baseballs and things that go, golf balls that move at very high speeds in sports actually stay visible. So they also added a feature called dynamic HDR support. It gets a little bit into the weeds, but this allowed for much faster transitions and dealt with the fact that you could go from a very dark background environment, like in a basement, and then move right out into direct sunlight. Well, they wanted to be able to adjust for those different ranges. That's probably oversimplified, but it's the easiest explanation I can come up with. So, so the easiest way to understand the difference between 2.0 and 2.1 is 2.1 is the current standard. They added a letter B, which didn't do anything for our picture quality. It was more on compliance and making sure that the source, the source of the signal and the display, or sync as they call it, where it syncs into, that they had more standardization in their communication. So that's probably where, mostly where we are now. In the anatomy of a cable, if we can stay all copper, we're not translating from copper to light or copper through a chipset and boosting it or compressing it and then decompressing it, and then there's less going on with the signal. In what we call a passive cable means it's point to point with copper. All right, it could be a positive and negative. We don't transmit ground. We want those to all be shielding more than transmission. So the problem is the maximum length we have seen that can reliably be passed over a passive cable, no electronics, is about 9 meters.
And why is that?
Because of just the properties of electricity and resistance. Basically, copper, the signal deteriorates, if you will. It's absorbed. I don't know the best actual verb to use for it, but it can only go so far, and it weakens. So our displays kind of go, huh? Could you send that again? Now that's called error correction. And there's lots of errors, but it's traveling so fast back and forth that we can lose data, for a very, very, very minuscule amount of time, and it has no effect on the picture.
And that does happen. Error correction in HDMI is actually very good.
Actually, it's an essential part, because if we didn't have the error correction at the speed that it occurs at, we would lose, our pictures would blink a lot while it tried to refigure out what was going on. So people wanted to go longer, still wanted to use copper. So that's when we saw these chipsets at the source end and the display end. And those are directional, by the way. There's something we're sending, and then there's minimal coming back, but we need to get that handshake. So if we take the ends and you don't pay attention to a directional cable, or what we call an active cable, it just doesn't work. And it's a heartbreaking thing to get a call from someone who's installed the cable and the drywall's up, and they go, I can't get a picture. And I have to tell them, you got it in backwards, and you can't, there's just not a fixer for that.
Nope.
So any rate, so the next level was moving to fiber optics, which fiber pretty much laughs at these bandwidths. Fiber optics has upwards of 100 gigabits of bandwidth over a single strand of fiber.
Before we move there, what were the actual chipsets doing in the active cables that were copper?
We have voltage coming in,
mm-hmm.
and it converts it from that voltage into a encoded beam of light. It's very wide bandwidth. I believe the term for this device that converts from copper to light is called a VCSEL. And that's
now, was it doing this on the active copper cables? What was it doing there? It was doing that there
the
too?
active copper cables, what they were typically doing is, as the pipe gets bigger in
mm-hmm.
terms of how much we're supplying, copper has a smaller capability.
Mm-hmm.
So we compressed slightly. And then with the chipset, and we sent it down the wire, and at the other end, we expanded it back.
Okay.
The cliche analogy is concentrated orange juice. We take real orange juice, we boil away or remove the water, we evaporate the water, and we ship it in a more concentrated form. And if we added exactly the same amount of water back, it should be exactly the same juice. Now, most of us know, in tasting fresh squeezed versus concentrated, we know that it's not exact. So there are some things that get lost in translation process. And there are many fine products that do really an amazing job. An HDVAC extender, where we come in with an HDMI cable, we compress it, we send it over data cable, category cable as we call it, which are 4 twisted pairs, and then we come into a receiver and we decode it and put it into an HDMI cable. And those chipsets made by HDVAC and other companies have some proprietary ways of handling it, is a great way, but to get from point A to B. But there are trade-offs visually, and when you get into exceptionally high quality sources like MadVR, we pass it through Anthem or Trinoff or any of these brands that are routing the signal. We want to switch different sources, but send them all out. It becomes a constraint in the transmission line if we don't do this right.
Okay. Sorry to interrupt you. So
No.
now we're back into fiber optic AOCs, and you were talking about chipsets. I just want to make sure that the viewers and listeners knew about what the active copper cables were doing.
Yeah, active copper is out to 9 meters, but the cable gets fat. We need a larger gauge of copper so we don't lose voltage over distance. It's like resistance in speaker wire. A larger gauge of wire will allow more current and voltage to go through.
Now, so people are going to ask, well, why don't you just increase the voltage that you're sending it? Because then you could increase the distance of the passive cable.
Well, then we'd have to regulate it because the source has a certain amount it puts out.
Mhm.
If we put out more, and that's where we ran into Apple TV 4K, they were over voltaging. And Roku, I think, was doing it for a while. They were over voltaging and figuring, well, let's just pump more down. Well, putting too much voltage in, imagine it was a light bulb and it was screwed in and we had 120 volts, but we increased it to 140 volts. It'll glow brighter, but it'll burn out and fail sooner. So some of these chipsets just could not manage that over voltage. In fact, it's pretty narrow tolerance. So it sort of sends everybody out of whack with each other.
Okay.
So the next step was, how can we go faster than copper? And fiber optics was the solution. Now, originally we just called them active copper cables, ACC, but nobody ever remembers that acronym. We went to active optical, or fiber optic, and the acronym there is AOC, that's active optical cable. It also uses copper. All we're sending is the tough stuff, the really high speed, fast stuff, which is the video signal. A lot of other signals that are transmitted back and forth, the handshake and some other synchronization voltages are a steady voltage. Some are pulsed, but generally speaking, we just need the voltage to stay constant and we need our timing to stay constant. The other thing that was introduced was a concept where someone has, I think the smart TV really bore this, which is I have a TV in my bedroom and I have an audio system back at a rack and I have an amplifier and it sends the signal up to my speakers in the wall or in the ceiling. And I have my sources are back in the main rack. So I can select in my master bedroom what I want to watch. I'm really selecting a source from way back there. And I have one HDMI cable that sends it. And we're really just sending video, even though the audio would be present if I wanted to listen through my TV speakers. But my audio system sounds much better. Plus, I can also send back surround sound in whatever format, 5.1, 7.1, 2000.1, whatever system it is. But with the advent of the smart TV, a new variable comes into play because the TV can be the source. Mm-hmm. So we have a smart TV, I can activate Netflix, but the amplifier is way back yonder. So a technology called audio return channel, or ARC, was developed. And it allowed us to receive the video from a remote area or select the app that's in our TV. So the video is coming right from the app right onto the display. We're not sending it back to our rack and then sending it back to the TV. So I have my video, but I want to listen to the sound through my audio systems, and that equipment's way back there. So the concept is I'm going to, because I'm using the video, the source in the TV, I'm going to use that HDMI cable and use it in reverse. But I'm only going to send audio. And I'm going to return the audio back to my main equipment rack. And now, even though I switch sources, all this can happen automatically with the right equipment. And I'm listening now through my audio system, sending it back. A later version in the HDMI 2.1b specification added another dimension to that, which is eARC, small e, capital A, capital R, capital C. That is enhanced audio return channel. And it added more surround capabilities so that if a source in your TV, and not all of them have this, had, or whatever source, the service, whether it's YouTube TV or Apple TV or whatever, will be able to send back even higher density channels. So you can get 7.1 and beyond. We have DTS 2.0. We have new Dolby standards, and now we can get those audio channels back. But it's only about audio. And in fact, there's a lot of people who will use category cable just to get the audio back. So that's sort of the growth of it. There are a lot of technical things that go on inside, And most of that is handled preferably at the HDMI forum and the licensing area, because one thing I will give HDMI licensing credit for is they have kept something that, people can't just say, I'm just going to do it my own way. They've got very tight licensing agreements. So, unfortunately, some people do figure out how to do something better, but it's got to be backwards compatible and cross compatible with everybody else on the market. Hence, and we deal with this a lot with MadVR connecting to a Barco or a JVC or some very, very demanding displays. That cable and that transmission, the connection between the source and the sink, becomes hypercritical.
Mm-hmm.
Copper resistance, a poorly executed chipset design in the head shell for transmit and the display, they all are going to affect this picture quality. And we're pushing the envelope past the edge of the envelope in a lot of these video signals.
Right.
And some of the sources that have really driven this hard is PlayStation 5, Xbox Series X, Series 10. They offer full 2.1 support, and trying to use your old HDMI cable you bought in 2005 could be the limiting factor.
So let's talk a little bit about how HDMI 2.0 differs from HDMI 2.1. How does a signal traverse HDMI 2.0? You'll probably see when people are talking about HDMI 2.0, people talk about TMDS. And that has to do with how the cable is sending information and vice versa. So let's talk a little bit about, at a high level, how the cable is operating. Like what does it go through? What things does it have to do in order to make this work? And a big part of that I don't think gets talked about enough, because people are always like, oh, well, it's just not receiving it. And you've mentioned this a couple times, is how important timing is. And if the timing gets off, nothing really works, or things just don't work correctly.
Well,
like air correction is only so good.
Yeah. Well, part of it is the timing aspect is literally a metronome, that when you have 4 lanes plus a lot of copper, things are not necessarily going to arrive. It'd be like we let 4 horses out of the gate. One of them is going to get ahead of each other. Mm-hmm. Now, it's not about who the winner is. We need everybody to show up at the same time. And there are ways to correct for that. And if something gets behind, it's usually latency, something being behind, that is the problem. Very rarely is it something is going faster than it's supposed to go. So that correction. The other aspect of it is what the display, and it's not even, that's why they call it a sync. Because if I come from a source and I go into an AV receiver, or what we call an AVR, the AVR is a sync. It literally has to take the HDMI signal, take apart the major components of it, and then put them back together to send it out as a source. They become a source now, and send it to the next sync, which is usually a display. But it could go into an HDMI switcher, so I can bring that input in and switch it somewhere else. So there's a lot of possible encoding, decoding. Mm-hmm. So the 2.1 spec stabilized how you do that. Because here's the beautiful thing about digital. A 1 and a 0 just has to remain a 1 and a 0. If we keep it all timed together, everything can be taken apart, put back together. It's like copying. That's why there's copy protection and what we call HDCP, high definition content protection. That is mandated by Hollywood, so to speak, the content creators, because if you didn't have some sort of key or decoding lock, if you will, on the signal, you could get an original digital copy and you could make zillions of, you can make copies of copies of copies of copies, and they're all going to look like the original. So a lot of what HDMI did was include this HDCP. It started off with geez, I don't even remember. I don't even have a version number 1.0. We've gone to 2.0, then 2. We're now at 2.2, I believe, is pretty much where we've settled. And it poses issues because if a product isn't compliant, it's not licensed, it's not going to transmit. It has to be HDCP 2.2 compliant is a very important thing to look for.
So what is an HDMI source actually sending out? Like, what is it? Let's break down its signal a little bit. So what is it actually sending to the sink?
You are digging into my brain.
I'm going to dig in a little bit, and then I think this is as far down as we're going to go. And I think we can talk about this, the intricacies of it, in another video. But I want to dig in a little bit of it, and just so people have an understanding about how much is actually going on in your cable. Because you've got the video streams, you've got EDID information, you've got the voltage by itself going, you've got HDCP information going, and more than that. There's just a lot going on.
Well, the video signal is probably the easiest for most people. We're sending a picture. Yes. We may be, putting it into 3 or 4 different lanes instead of trying to get it all to go in one lane. That it just becomes super costly to do that much encoding and put it into a beam of light or into a voltage. But we do have, and you've mentioned it a couple times, EDID, which is Enhanced Display Identification Data. Mm-hmm. And this was actually developed for computer monitors. When you plugged a monitor into a computer, they actually talk to each other, and we didn't know what resolution display it was. Was it 480i, 480p, 1080i, 1080p, or 4K now? So that handshaking went back and forth, and I don't remember the standards body, but EDID is a totally rock solid standard. It's a library of what a display could possibly do. So if I'm a source sending something down an HDMI cable, I pretty much have to find the formula that display can do. And I want to walk up the ladder and say, well, what else could you do? What's the most you could do? And all this communication happens in an instant. So once they settle on what can be done, the source will lock in, and that's what it's going to send. So there's one lane, if you will. HDCP, it generally is on a pair of copper wires. Originally, it ran on the 5-volt line, which was also sending the poke in the ribs to the display saying, hey, anybody out there? And the display would wake up and say, yep, I'm a Samsung or a Sony or whatever brand of product, and it sends back its EDID data. We also have this audio return channel. That is on another lane of copper. Now, some of these are piggyback. Sometimes there's, it's sort of like a tow truck. It's not only the tow truck, but it's what's hooked up to it. So some of these, oversimplifying here, but some of these communications are happening at different frequencies on the same lane of copper.
Okay, so we've got EDID, we've got HDCP, we've got audio. That doesn't include the audio return channel or eARC or any of that. We have the video. Yep. You have the normal 5-volt line for powering the sink, because to stay in compliance, the source is actually powering both sides. What else am I and I'm sticking with HDMI 2.0 here. What else? Am I missing anything outside of those? So HDCP, EDID, 5-volt power, video.
There's some things that were developed for gaming, to add communications that there's variable refresh rate. It reduces or eliminate any lag and stutter, they call it frame tearing, for better and more fluid detail. Because in gaming, anything that lags means you're going to get shot or killed.
Do you remember where that was introduced? What revision?
2.1 was the biggest steps.
Okay.
2.0 really addressed some gaming features, but the 2.1 had a lot of gaming. They also had quick media switching, or they call it QMS, and that was for movies and video. It eliminates the delay that happens when a device changes from one HDMI frame rate to another. Sometimes that happens during the movie. And, a lot of these nuances just happen automatically. So it isn't something that we know is going on, but they wanted to allow for the the actual video stream to have that type of flexibility when they encoded it.
Right. Now, another thing on HDMI 2.1, so 2.0 to 2.1, you have TMDS going to FRL. So what is the difference between TMDS and FRL? If we can talk about that real quick.
Well, I don't know that I can give you a technical answer.
High level's fine. I think we'll again readdress this in another video as we dive, I think, a little bit deeper into what makes up the HDMI cable, but I think high level would be a good starting point.
Well, it's kind of an intricate world. I mean, when you're distinguishing between TMDS and FRL, the terms continue to shape everything that we're doing. I would say probably the best high-level explanation is, so TMDS stands for Transition Minimized Differential Signaling, if I remember right. And FRL is Fixed Rate Link. And there are two different methods for transmitting super high-speed data signals, mainly in our case, that's what we're using in HDMI. It's just the way they're implemented and their bandwidth, the capabilities they have. TMDS is used more in HDMI and DVI, where FRL was used in DisplayPort. And DisplayPort interfaces have a little bit higher bandwidth. So DisplayPort is actually capable of 8K, was capable of 8K before HDMI was. So there are two different methods. There's been some discussion about trying one in the other and flipping them, but I think really TMDS has been the more stable for the HDMI realm. At least, again, I don't work we don't make a source. I don't sell any sources, and I don't sell any TVs. I sell what connects them, and I'm looking for a clear, open pipe that's not going to limit the technology.
Right.
And TMDS and FRL travel in the same space. So as long as my lane is wide enough to take a sports car and a semi, I've got the lane needed.
I got you.
Yep.
Okay. That makes sense. So again, we're going to talk about these in a little bit more detail, I think, in a future episode, but I wanted to get kind of a high level definition of what they are, and effectively they're just how data is transmitted.
Yeah. And also, TMDS generally operates in that 18 gigabits realm. And when we went to 48 gigs, it was just modified. We're seeing FRL in USB 4, right? DisplayPort and USB 4. So it's a different method, but USB has a completely different ability to transmit. And I don't know, this is just an offhanded prediction, but we will see USB becoming a more viable way to transmit video signals versus HDMI. I think you'll see more of that soon. And I also think the day may come where we have a fiber connection directly. We're going fiber to fiber, and we aren't trying to build electronics and chipsets into a cable with so many different wires in it. Because even with an active optical cable, we have four lanes of fiber, but there's still, I think, another six pair of wires still transmitting voltages. So versus 19 individual connections. So what would that have been? 3, 6, 9 plus, so about 5 other connections. So there's still connectivity between the ends over copper.
And that's usually where your problems arise.
Well, only because copper is more fallible than laser.
So what are your most common failures in HDMI? Where do you see things most commonly just decide not to work? Like, and what do those failures typically look like? HDCP is an example. A lot of times manifests in either a black screen or a persistent, I'll call it a flash.
I will tell you that probably the most prevalent troubleshooting we have involves what I would call a lower level source. the companies, Xfinity, Comcast, DirecTV, the streaming services with a set-top box. I'm convinced that unless a set-top box catches on fire and they have to throw it away, that when you discontinue service and turn that box up, that is going in some grandma and grandpa's house. They just test it. It still meets spec, and they ship it. I was telling you before we started this, I had a guy who was having massive, like, white flashes on the screen just periodically. And I said, well, I always try to get to what source are you using? And he goes, well, it's worse on the, turned out it was only on a DirecTV box. And I'm not slandering DirecTV. It's a great system. But I said, do me a favor, turn the thing up over on its back and look at the bottom of there's a sticker on there on its belly. See if you can find any sort of a date, or worn on date, I like to call it. And it was July of 2015. And here we are, we're in 2025, and we're using a 10-year-old box to try to drive a fairly sophisticated, this wasn't a high-end Barco projector, it was probably a Sony or Samsung display, but brand new technology trying to receive data from a 10-year-old product. I said, see if you can just get them a new DirecTV box. It's a customer, tell them it has problems and you want to swap it out. So usually, and there's other low cost. I mean, sometimes you're using a $49 streaming device to drive a really sophisticated $5,000, $10,000 system. It just blows my mind. I mean, come on, it's like putting retreaded tires on a Porsche. It's going to affect the handling.
Right. And theoretically, that DirecTV box should work as long as it's meeting the requirements, like HDCP's up to snuff and it's not under not a new enough version and backwards compatibility.
There's simple things that cause problems. The HDMI port, I think I said earlier, it's fairly robust.
Yes.
But, plugging it in, and if the cable gets some strain and is bent, you've got 19 pins that are all lining up in there, and we're doing this routine to it. We find a lot of port failure can be a problem over time.
Yes.
So, and some HDMI cables have these massively long head shells and big fat, woven jackets that make them look like $1 million. It all adds weight and creates more stress on the connection.
Yep.
And the strain relief on an HDMI cable where the head shell meets the cable, it is probably the most critical part of the construction mechanically of the cable.
Then you can run into issues that I would assume can manifest as sporadic, right? As things start to heat up and you don't have a solid connection, your voltages can become irregular. You can have all kinds of funny things happen. And that's kind of where I was going with the DirecTV box stuff, is things can eventually deteriorate or wear out, and heat does some amazing things to products over a period of time.
The bane of any technician's existence is an intermittent problem. So troubleshooting 101 is don't change more than one thing at a time. If you just pull out several products, you change the source and you change the cable, you don't know what's really, and you still have a problem. Well, it wasn't those two things, or
right.
It could be, it's usually two things trying to interop with each other.
Right. Well, Eric, I know you said you had to go, so I don't want to keep you longer than we need to. I loved having you on, but I don't want to keep you from where you need to be. So I appreciate you coming on and shedding a lot of light on what HDMI is, what its history was, how it works, and giving the people, I think, a really critical message in both making their lives easier and making the industry a better place. I think that's where Future Ready Solutions stands, and it was a big reason why we wanted to have you on. So that's
what's that old adage? The appeal of a low price wears off quickly, but the bitterness of poor quality remains forever.
That's a good saying. I like that one.
I think my grandfather told me that.
Yeah, that's a good one.
It's great talking to you guys. Eric, thanks for all the work you do on ABS Forum.
No, my
It's
pleasure.
a
Thank you
labor
so
of
much
love,
for
I'm
joining
sure.
us. And
And I appreciate it. I'd be happy to come back on whatever topic. I
Yeah.
certainly can talk.
Yeah. Well, we really appreciate it. Thanks for joining us for episode 4. Before we get into what episode 5 is going to be, a quick word from our sponsor.
Anthem delivers precision engineered sound, blending cutting edge technology with an unwavering commitment to excellence. Experience clarity, power, and sophistication that define the pinnacle of audio performance. Visit your local Anthem dealer or learn more at anthemav.com. Anthem, elevate, refine, enhance.
Again, thanks for joining us here today for this episode 4 of The Front Row, brought to you by Anthem Electronics. It was a pleasure having Eric Bodley on with Eric Wesley and myself to learn a bit more about the history of what HDMI is and how it operates. Episode 5 is going to be a more granular journey and dive into what HDMI is, what it's made up of, how it operates at a much more granular level, and then how issues present themselves as they come about. Because in actuality, different issues as they come up look a little bit different in how they present themselves on a screen or in your signal chain. So again, thanks for joining us here on episode 4. Episode 5 will air on August 5th. Again, that's going to be about HDMI in a more granular sense, its inner workings, and what the air cases look like. So again, thanks for joining us. I'm Ryan. This is The Front Row, and we will see you guys next time. Thanks again.